think about a science fiction movie that you've seen where the computers chit-chat with everyone. You know, like they're one of the characters, right? Like it has emotion. Is that actually possible? Today, we learn more about AI. One of the annoying things about artificial intelligence is that it just doesn't understand me. You know, you've all been there, right? With either Siri or Google or whatever it is that you use. You feel like it doesn't understand you. You know, you ask for the baseball score and it tells you the history of baseball. Okay, that could be a problem. However, in some cases, and some of the research and some of the stuff that I've been looking into on this, well, understanding input is not really what they're made to do. They're looking for patterns in the input to replace that with the answer and to give you the proper information. So are they really meant to understand us? Well, I don't know. So, okay, those patterns have been given to them by large data sets. I'm not the person to tell you about this. Don't worry. I've got a guest that's going to help us learn a lot more about this. But is it possible to allow an AI to truly understand us by using common sense? It could be tough. I mean, it's tough for even some people to have some common sense sometimes, right? I've had some issues in various times of my life. Okay, so if they start to understand us better, where will it lead? Are those advancements actually welcome? So let's learn more today about AI and common sense. I am joined by Mayank Kejriwal. He is a research assistant professor of industrial and systems engineering at the University of Southern California. Mayank, thank you for joining me.
Thank you.
I think we should start at the beginning here. I just gave a little example of what AI is, but you can tell us a lot more about this. So give us an actual definition.
Sure. So I think the best way to define it is that it's a system and usually a piece of software that is capable of learning. So, it's a system that can adapt to data sets that you give to it. So, for example, if you have an AI for doing face recognition, we give it a large set of faces and it learns to recognize those faces. So when it gets a new face or it sees someone's face in a different setting, like, in a different bedroom or something like that, it would still recognize it. And so this is what you see in your iPhone and in your, in your Android. And the same technique, which is usually called machine learning, these days it goes by deep learning, applies in a whole lot of domains, everything from speech recognition, your Google searches, and, all of that is really powered by machine learning, which is the dominant form of AI.
So is Google's algorithm actually an AI?
It depends on which algorithm we're talking about. So if it's the one where you type in a search query in Google and tries to understand what you're asking for, then, today that is powered by AI. But when Google first came around, it was using very traditional algorithms that had been invented in the web community. And that was not the adaptive kind of AI that we think of today. However, the recommendations, like when you get recommendations from Google, like advertisements, then that is powered by AI. So that definitely would fall under AI when you see advertisements.
Okay, so this is a very kind of narrow AI because that Google algorithm is basically doing one thing for you.
That's right.
You searched, what is so-and-so's birthday, and it gives you that result because it understood that celebrity's name and the keyword birthday, and it popped out an answer. So it's very narrow AI, basically made for one particular purpose. And is that generally what we're dealing with right now?
I think so, at least in the commercial applications. So, whether that's it can change a little bit depending on the application, the algorithm. So, for example, if you go to Netflix, it's recommending movies to you. The underlying algorithms are very similar. They're not identical, but they all rely on a small set of techniques that have been refined in the AI community over decades, specifically for recommendations. And so, you might see different versions of it. You might see proprietary versions of it if you go to different platforms, but they are still very heavily tuned for one application, and that depends on the company. And you're very right that, when you mentioned a celebrity name, right? Google can tell you about a celebrity if the celebrity is there on Wikipedia or on some website. But if you just ask about some entity that is not in Wikipedia, it would have a much harder time. So even in the search problem, which is narrow, it's there's a long tail that it can't deal with, and it's mainly for the common entities, the celebrities, the places, landmarks and cities and so on. For the long tail, it still has trouble answering even those questions.
There was this movie, I can't think of the name of it right now. Oh, Bicentennial Man with Robin Williams, where basically he's a robot that understands everything. That's not narrow now. That's kind of now more of like a general knowledge. So I believe that's artificial general learning. Are we far away from like that type of thing?
I think we're pretty far away. So the term that is usually used is just called AGI, so artificial general intelligence, and sometimes it's equated with the singularity. So you might have heard about the singularity that Ray Kurzweil and others have proposed. They thought it would be here by 2029. So we're still 9 years away from that. So technically, they haven't been proven wrong. But given the technology that at the pace that is progressing, we're making massive progress, and we have made massive progress. But, there was a book recently by Martin Ford where he went and interviewed and surveyed a lot of AI experts, and he asked them, when do you think AGI will arrive? And on average, the response was that by 2099, there's a 50% probability that we'll have AGI. So there's a lot of uncertainty. Some believe it's 10 years away at minimum. That's the most optimistic scenario. Others believe it's 100 years away. I suspect that the correct answer, as always, is probably in the middle somewhere. So I think we might see it in our lifetimes, but it's not here on the horizon yet. We need to make a lot of fundamental breakthroughs before I think we will get there.
If only there was an AI that would tell us.
That's like a meta AI.
Answer its own problem there. Okay, so we're talking about, is it possible and when is it going to be here? Well, okay, now let's ask, should it be here? Like, is this something that we should be afraid of, or is this something that we should welcome?
So I think the technology itself is not dangerous. But I do think that if we give it more and more power, especially in things like prison sentencing, in whether what bail to set for someone and whether to allow someone to be out on bail, we kind of know now that many of these AI algorithms are biased, and that's in part that is because of the training, because a lot of the data that we have is biased. It's been produced by biased societies, right? And then the AI is trained on that. So it's basically picked up our history, which is not very good when it comes to relations with certain groups in society, right? We don't have an ideal spot record, as humans.
Oh, that's interesting.
And so some of that is reflected in the AI. And so that's the fear. And then if that gets implemented in many organizations, I mean, we've heard stories, for example, that in some companies, they use the AI to evaluate workers and to hire and fire workers and, all of that kind of thing. And so I'm a little bit cautious or a little bit concerned that we don't want it to have too much decision-making power till we are ready. And there's something dehumanizing, I think, about it. Even if the technology is there, we have to think carefully about whether the technology is dehumanizing to people who are adversely affected, because you get fired by a person and you get fired by a machine. I just think that there's something that doesn't seem right about the latter. And so maybe we'll change as we get to trust these machines and they become more like us, maybe. But I do think that we have to think very carefully about those things. So we should be concerned about some of it. But the technology is not inherently dangerous. I think that it will come whether we want it to or not. So we have to be ready for it as a society.
The prison sentencing, what you mentioned there, like that sort of hit me. It's like, okay, we would potentially be training the AI that's producing this with really bad data, with data that is not, and so it's going to just continue that pattern of the mistakes that were perhaps made in the past.
That's right.
Wow. Yeah. That's interesting. I like that one kind of hit me. And then the other thing, to hit me here is I could argue both sides of AI being in charge of hiring and firing. With AI being in charge of it, you're taking out all of the I guess you're really making it, we've all heard the, oh, it's just business thing. You're really making it just about productivity or, whatever it is. You're not, picking and choosing somebody based on who you like or dislike,
No,
or,
and that's a very good point.
if their lunch smells or something.
Yeah, and I want to say something about that. So there was a recent book by Daniel Kahneman, who wrote Thinking Fast and Slow, and the book is called Noise. It just came out earlier this year, and he made it's not related to AI so much, but it's related to this human bias. Where what he showed was that in sentencing, for example, or even in insurance adjudication, where you file a claim and then they decide how much to give you and whether to investigate your accident or whatever it is. It turns out there's a lot of noise. Like you can give the same case to different adjudicators, even within the same, or claims adjusters within the same company. And they actually did this, and they found that there's a wide range there's a dispersion, which is very big, and it can't be explained by simple statistics. There's both bias and noise. So certainly by using, a system which is more reliable, which gives you the same result each time you use it, we can get rid of the noise. So that's one thing to remember, that it may get rid of the noise and it may also get rid of some biases, but we also want to make sure that we don't introduce other biases, while we're at it, and also that that there are consequences if there's a wrong decision. So I think that one part of this is that, okay, you can make the wrong decision, but if it's proved that you made the wrong decision, that you discriminated on the basis of age or sex or something like that, some protected characteristic, then you can be held responsible, as an individual or as a company. And so I think we have to be very careful that we hold the AI up to the same standards. So if a company is using an AI to do that, then the company should be liable if the AI is making those wrong decisions as well, and it's proven that it has a bias against certain groups.
Mm-hmm.
So I just think we have to be more careful. But I do think that using a system can reduce noise. So that's a fair point.
I don't know how much baseball you watch, but you watch the way that they have it set up now. You have the box, the strike zone. You actually see it on TV, and then you see the little dot appear where they threw the ball,
Mm-hmm.
and it's clearly a strike. But the guy standing right behind there, the umpire, calls it as a ball, and you're like, what? This guy's wrong. And now they've done calculations on that where they're wrong a certain amount of time, but it's generally fairly even where they're wrong for both teams. And there's all these calculations going on right now about that. That's sort of like, in a way, I guess, AI checking us, right?
Oh, yeah.
Sort of.
I think so. And I think that's, we want the best of both worlds, so I think that's the ideal situation, right? Where we have what we call augmented AI, where you augment the human or humans with AI. And there's a lot of research going on right now on human machine teaming, for example, that can you have both humans and machines, which would be, whether that's a robot or a software that, together are trying to solve a problem. And I think we see this very beautifully in some more recent science fiction movies, which are not black and white in their portrayal of AI. So the one I'm thinking about is Moon. There was a movie called Moon, where there's a guy who is on the moon, and he's the only guy on the moon, and he's there. There's some company has put him up there to mine or oversee the mining operation. And there's an AI, and he tries to solve problems with the AI throughout the movie. I thought that was very realistic, the way that was shown, where it's not a black and white. And so I think we need that kind of thing where it's augmented, so there are checks and balances, and we try to understand, okay, this is where we need a human, and this is where the AI can actually check us.
That's almost like kind of like a real magic 8-ball, You make your decision, and did I make the right decision? And it's telling you, oh no, did you think about this, and this? Like that actually is kind of a cool use.
That's right. That's exactly right. Yeah.
Wow. Okay. I am excited about this conversation, but unfortunately, I've got to take a short break here. So when we come back, we've got plenty more to talk about and learn about AI, AGI. We're going to get into some pretty cool stuff here, and we will do that right after this. If you enjoy history, maybe you're just feeling a little nostalgic, or you wonder who's having a birthday today, or maybe you need a reason to celebrate. Well, we've got the perfect podcast for you. It is called This Is Today, and each and every day we talk about the historic events, celebrity birthdays. We also talk about whatever is going on today. There's always something to celebrate when you listen to This Is Today. And at just 10 minutes each day, you can make it a daily habit. You can even add it to your Alexa Flash briefing. Click the link in the description or just search in your favorite podcast app for This Is Today. Thanks for listening, and thanks for subscribing to Learning More. It's Russ with you. I am having such a great time with this. And I've just got to tell you, I'm talking to a real person, not an AI. He's joining me today. He is a research assistant professor at University of Southern California. So he's got some credentials behind us, and you've done a ton of research on AI. And I'm thankful that he's able to share that with us today. So Mayank, I think about driving cars.
Mhm.
Okay. So in driving, you make so many little decisions, right? Now, okay, so we talked about narrow AI. If we had just a straight road and there were, no stop signs, no other people, and it was just completely straight, that seems like to me very narrow AI. That seems very easy for, a system to just take over and do.
That's right. That's the Tesla, right?
Yeah,
In the
yeah.
ideal situation.
We know if you've ever driven. I just went down to LA not too long ago.
Oh my gosh.
There's no AI there. I mean, you can't. You're making constant decisions down there every second.
Oh yeah.
So how do we teach a computer and how do we trust that, I guess, is the bigger question here. How do we trust all of those kind of complex decisions that we have to make second by second to an AI with a self-driving car?
Okay, so that's a great question, and we should first recognize why the problem is there, why the question got raised. It's because we live in what we call an open world. So an open world is one where you don't know everything. In essence, like we say that the world has structure, the world has parameters, but not all the parameters and structure might be known, right? And so the real world, even the highway system, and the world of roads and cars and highways, even if we don't go beyond that, is still an open world because you're going to see all kinds of corner cases, right? You're going to see the case where there's going to be a pile up somewhere and you have to slow down and you have to navigate that.
Right.
Things like the person in front of you might suspect is drunk, because they are driving erratically, and you probably
You're describing my trip in LA, actually.
That's right. Yeah, you want to be careful, right? Either you change lanes or you're just a little bit more alert, And so it's just, there's so many corner situations, and we don't have an AI that can actually do that yet, and maybe that's why we don't fully have self-driving cars. A lot of people thought that by now, by 2020, 2021, we would have self-driving cars on the street. I think Elon Musk went out and was on record saying that by now we would have 1 million self-driving cars. I don't blame him for being optimistic. I kind of like that, to be ambitious and optimistic, but it kind of just shows that when you're in an open world environment, you can solve 80% of the problems with very good technology, but the other 20% could well take the next 20 years. And we can't just wish away the other 20% because people's lives are on the line, right? And so that's the kind of research that we are doing, which is that how do we build AIs that can operate in the open world, that can deal with unexpected situations. And self-driving cars are a very good example of that. Not the only one, but a very good example.
I've not dealt with the same, drive ever twice. There's always something different that happens. So how do you even get a data set for that? If it's true data set that needs, how does that even happen?
My thesis is that we should, and that's why I think it will take decades, is that I don't think we can't learn from data, because let's think about the hypothesis, right? Like as humans, every drive you've taken is different, but you haven't taken that many drives, compared to what the what the Tesla system is already trained on. Like another example that may be more intuitive to a lot of people is just reading and writing, right? Like if there are many, when you read a book, you've never read that book before. If you've read a novel, a lot of times you've never read that before, and it might be very unusual. The language might be unusual. The characters might be unusual, and you're still engaged. You still get it. You still feel the emotions and the characters if it's well written. But think, a machine still has a lot of problems with that, even though the machine has read a lot more than you have. It's read the entire web. It's read the entire Wikipedia, which I don't think any human being has. It's read like more books and news articles and Wikipedia and all of that. and it still doesn't have the kind of comprehension and the kind of common sense that we do. And so, what a lot of researchers are now arguing is that we have to think about this in a very different way. That the problem is not data; we already have all the data. We need something more fundamental, something that goes beyond the data. Like some change in the model, because we're not learning everything we should be learning from the data. And so the answer is not more data. There needs to be something more
Mm.
fundamental that makes the AI more powerful. Now, what that thing is, there are lots of people who have lots of ideas on that, on what that magic thing is or magic things are that will get the AI to a human like reasoning ability. But we don't know for sure yet. And that's why I think it might take many years, it might take decades before we're there. But you just pointed out the problem, which is that we no two situations are exactly alike, and yet we're
Hmm.
able to deal with most of them. And how do we make AI anti-fragile, which is that when what doesn't kill you makes you stronger, right? And it's we don't have that
Right.
level of adaptation yet, where the AI basically it does not get stronger, and that's the kind of thing that we need. We needed to have a different kind of adaptation, the kind of adaptation that humans have. So I think we're not there yet. That there's a missing ingredient in this, and we don't know what that is, and that's why it's really exciting to do research, because we're trying to find that missing ingredient. Um, yeah.
And so tell us a little about that research and kind of, what you're looking into right now with kind of the future of AI.
So one of the things we're looking into is common sense, and what is so fascinating about common sense is that we can't really define it. It sort of defies definition. And there are some
Hmm.
famous quotes from, philosophers and writers who have said that common sense is a wild and savage thing that is beyond rules. And so in that sense, it's a lot like language, right? Like when you think about the English language and even other natural languages, any natural language that humans speak, it's very different from formal languages, from a mathematical language, from a computational language like developers code in. They have very strict rules. And if you don't follow the
Yeah.
rules, the program will not compile. So there's something about human communication, about human thinking, about common sense, which is inherently human, that is very irregular. There are lots of corner cases. There are lots of tricks that we use, lots of heuristics, lots of rules of thumb, and sometimes it goes wrong. That's where the bias comes from. But by and large, it works really well, right? And it's gotten us this far. So by and large, it works really well. So we're trying to give common sense to AI. That is one of the things we're doing. We suspect that if AI has common sense, then it will be able to deal with some of these, situations. Even if it hasn't seen the
Right.
situation, it can apply common sense, which is a very general principle, to the new situation, and then try to figure out a solution for that. That being said, it's proving very difficult to give the AI common sense, but we're making a lot of progress on that. So that's one research that's one trick. Whether you want to call it a trick or an ingredient, I think maybe ingredient is
Hmm.
a better word. That's one ingredient that we think that an AI needs to have if it wants to deal
Hmm.
with all of these corner cases and all of the richness and the messiness of the real world of open worlds.
Yeah. In one of the articles you wrote, you talked about basically they were going to order some pizza, right? And they're like, oh well, we know she stopped eating meat, so maybe we should just order a margarita pizza, so that uh, and that is a decision that can be made more like by a human. Just, oh well, common sense. Like, she doesn't like meat, so let's get this.
That's right.
And having a computer system actually make that decision, I could possibly see that happening at some point relatively soon, like decisions like that where it gets to know your tastes. Just because I'm thinking of like Amazon, right? Like Amazon knows everything I'm going to order before I order it.
Well, but I do want to dispute that, and I'll tell you why. Because it's not just taste recommendation, right? If it was a very narrow problem and all we had to figure out was, what should we order, then I think that would be an easier problem to solve. But like, think about what you're doing when you make a decision like that, right? There's a lot happening. So you're first thinking about. So we have this thing called theory of mind, what psychologists call theory of mind, and theory of mind means that we can reason not about our own beliefs, but also other people's beliefs. So, like, I know when I'm talking to you and I see that you're upset, for example, then now I know you're upset, right? And then I now need to get you to a place where you're not upset. and maybe I've said something that made you upset. And so I'm kind of reasoning about not just what I believe and what I think, but what you believe and what you think. And that's what happened in the pizza example, right? What we realized was that, okay, it's not just a taste thing. The reason we ordered margarita is because we know that if we ordered the pepperoni, then Susie would be very upset, right? Because Susie would not eat, and so Susie would feel left out, right? And so that's not a good thing. And so, and it's not. It wouldn't just be an inadvertent mistake because I know that Susie does not eat meat, and Susie knows that I know, right? So if
Hmm.
I forget that, I mean, imagine how it could feel, right? If you go to a friend's house and you know the friend knows that you don't eat meat, you had a discussion on this, right? That you're on a diet and you're going to go vegan, and now all of a sudden the friend forgets that and orders the pepperoni and there's no vegetarian option and you're hungry and you would be upset that the friend does not care about you and so on. So there's a
Right.
lot of complexity in this, and it's not just a taste recommendation, right? We are
Right.
thinking
Right.
about the agent in a very deep way, and you can expand this example to everyday interactions. It's just there's a lot that
Right.
we are handling in our minds all at the same time, and we're able to make decisions, while we're doing all of that, and that's what we need the machine to do. So we need that's one aspect of common sense. We have argued that theory of mind is actually a very important element of common sense. And we need the machines to have theory of mind, which they don't right now.
Okay, so I guess it's further off.
Oh yeah, oh yeah. I think years away. Not
Unfortunately.
decades, but
Well,
years.
that's the thing. I mean, you think about it. I mean, you can sort of see a world where you walk into your house, you've got your cameras in your house, and you've got the video screens and whatnot. I mean, it's almost like your devices in your house could almost potentially detect your mood. You come in, you throw your bag down, and you're clearly been upset, about traffic or whatever,
Right.
or your device in your house talks to your car and sees that you've been sitting in 30-minute traffic, and somehow it knows that, oh, maybe I should dim the lights a little or play jazz music or do something.
Yeah, and
So I could see that potentially happening at some point
that's right. Yeah.
relatively soon.
I think so too, and I think that that's the data-driven approach, right? Because it would learn from a lot of data that okay, this is what happens, like your Google Nest, that when at this time or when the person is feeling this or when a sensor records this, then I should do that, and so those kinds of rules and patterns, I think a machine can learn from a lot of data. But the problem is that when something happens that is a little bit unusual, um, then I think it trips up. And that happens often enough because there are so many
Hmm.
millions of people and so many different cultures. And that's also where the bias comes in because if it's trained on 80% of the data that it's seeing are from a certain kind of household, then what about the other 20% that is a little bit different, and that has a different profile, that has different tastes. And
Right.
so one of the fears that a lot of people are also thinking about right now is that far from AI changing to adapt to us, we might be changing to adapt to
Mm.
technology. Like when you navigate the web, when you write something on social media, or when you apply for a job, you kind of adapt yourself to that, right? And so if you do, and for job applications and for form filling, that makes sense. But imagine if that became your life. Like, if everything was, there was
Oh,
technology
right.
everywhere, then you'd be like, well, I have to behave a certain way. I have to change my behavior and have to behave a certain way because otherwise the AI might not recognize it. And so it happens
Right.
very automatically, but it's dangerous because it leads us to be adapting to the AI rather than the other way around. So that's a concern
Right.
too. Yeah.
Yeah. All of a sudden you're not buying bacon at the store because you're being tracked by AI. So
Absolutely.
buying
Yeah.
you're buying organic, or whatever. Making some big changes. I mean, maybe some of that stuff could be positive. Let's talk about the positive aspects of
Okay.
AI. Like, how is it helping us right now? What are some of the big things that AI is really lending a hand in to help society?
So I'm very excited about insurance. So I don't know too much about insurance, but I do know that some of the auto insurance and especially in auto insurance, what they're doing now is that they are collecting data from the hood of your car and from your car. And so the idea is that if you're a safe driver and you're driving well, then it's collecting all that data and it will give you a lower insurance rate. And if you're not driving well and you're very haphazard and you're just very erratic, you're a dangerous driver, then it will give you a higher rate. And I think that's very fair because that's the kind of data driven thing that we need. Because when it comes to something like driving, you're either driving well or you're not driving well, and there may be some corner cases, and I'm sure there are safeguards in place, statistical safeguards that it might average over like 10 days worth of data, so that if there's one incident, you would not get penalized for it. But that's the kind of thing
Right.
where people are paying a lower price if they're good drivers. But again, even and then same thing for credit scoring for other things, where if you're managing your finances well, then the models are more accurate and they are going to predict that you're not going to default. And as long as there's no bias and it's really making the right decision, I think that those things are all very good. I mean, even on Amazon and other websites, and if it's telling me exactly what I want, and I'm just finding what I need very quickly. I mean, I am very happy with that. It takes like 10 minutes and I have a full shopping cart and I don't have to look for things, right? So there are lots of small
Right.
benefits, and I think that there are some benefits where it directly affects your bottom line. I also think that in the healthcare system, in the sentencing system, for all its flaws, it may lead to an outcome one day, or it may already be getting there with all the attention on it, where it's leading to a less biased outcome than humans. And I think that would be an improvement too. So in all of those instances, I can see a lot of benefits. But we just have to be careful that we don't take it too far, and that it's not at the cost of a different group of people. So
Hmm.
we have to be very conservative about that assumption. um,
So, okay, if certain AI is trained by a data set, what about giving it a corrective data set, like what perhaps outcomes should have been instead of perhaps teaching it what they were? Does that is that kind of like tricking AI, and is this getting into something that's kind of dangerous?
I think it is of interest. People are looking at that, although in the opposite way. So what they are doing is that, let's say that you have a model for approving a loan application, and there's a profile that comes to the model, and there are profiles from two different people. They are very similar, but they are different only in protected characteristics. Like maybe one is male and the other is female, or they're two different races, and they might try to attack the model by seeing, okay, for one of them are you giving a positive outcome, and for the other one are you giving a negative outcome. So this is what we call an adversarial attack, where we are adversarially probing the system to see what its flaws are, because it's a very complex system. These deep neural networks are cannot be explained very easily. It's they kind of like the brain, right? Like it's just very difficult to know why you did something, and you can ask a person to explain themselves, but the AI does not have that capability to the same degree that we do to explain itself. And so I think that for that kind of thing, they are trying to explore that, are there using adversarial probes, that are there is the AI making biased decisions. I think the idea of inputting an ideal data set and training the AI is a very interesting one. I've never seen it applied in practice, but it's
Mm,
maybe because people disagree on what it means to have an ideal data set. Um,
right.
and we don't
Right.
have one naturally, right? So you would probably have to
Hmm.
contrive it. And then if you contrive it, then the argument might become that it's not realistic. So where do we strike the balance between realistic and artificial data set that is not reflecting what you might see in the real world? So
Yeah.
it's very interesting. I think the hypothesis that you put is a very interesting one. I mean, hopefully researchers are looking at it or have looked at it and are trying to see how far they can take that idea.
Yeah, well, I just feel like it's going to be like the insurance example that you give. Well, the kind of the not so great driver is going to really hate that. The dangerous driver is going to hate it. Like that's the data set. But if somebody gets in there and says, no, if they drive 75 in a school zone, that's like now you're getting into problems. Like so, it could just yeah, it could be crazy. So okay, last question for you. Like if you could predict it, like what do you see? The next like 5 years or so, how will our lives change because of AI?
Oh, in the next 5 years,
Yeah, I'm giving you a short timeline for this one.
I don't think much will change.
No.
I really do believe that. I do think that you will see a lot more adoption. I think the changes will be more social than technological. And by that, what I mean is, with the fintech and all these things coming around, and we have a very tech savvy generation, the Gen Z, that is coming around, basically grown up on social media and smartphones. So I think you will see a lot more adoption. You will see a lot more. I mean, people will. sort of take what the AI is giving them and even exchange their privacy for it, because the new generation is, more comfortable with giving up their privacy, I think. And so they want a very easy experience, and that's their choice. But I do think that you will see a lot more adoption. You will see a lot more uh, happening with misinformation. A lot more AI getting applied to misinformation. We're seeing that. It's kind of controversial, but we're seeing a lot of that right now. The COVID crisis showed that the drug discovery can happen, or the vaccine discovery can happen very quickly with the right technology in place. I think we will see AI being applied a lot more to drug discovery and vaccine discovery, that kind of thing. So we'll see a lot of that. I don't think we will have a robot that is, that will be like like the robot in the Jetsons, where
All right.
you have a robot roaming around your house and doing your laundry and cooking your food and making your bed. That's not 5 years away. That's a long time away. So
Oh man, well that's a bummer. Well, I can't even get my Roomba to actually like clean the whole house without having to kickstart it a few times. So
I know
I guess we are a few years away from Rosie.
we are. That's the name. That's
Yeah.
right. We are.
Yeah.
Yes.
Oh man. Yeah. Jetsons. I could tell you all about that. AI. I'm gonna lean on you for that one. Hey, Mayank, thank you so much for joining me today.
My pleasure.
Mayank Kejriwal, as I mentioned, he's a research assistant professor of industrial and systems engineering at the University of Southern California. I'm going to link to his research and to an article that he wrote. We'll try to get those book links in there as well that he mentioned earlier. I want to check out that noise book, so we'll get that link in there as well. I want to thank you for listening. Thank you for subscribing, and we would love to have your help on Patreon so that we can make the show even bigger and even better than it is right now. That would be awesome. So there's a link to Patreon in the podcast description. There's also a link to our daily podcast called This Is Today, where, I mentioned the Jetsons. I'll probably mention the Jetsons over there on This Is Today. Pop culture, history, all that fun stuff every single day. Why do you need to celebrate each day? Well, we'll tell you on This Is Today. Thank you again for listening. I'm Russ, and I will talk to you next time.